Alright, so in this problem, I have x to the power of x to the power 4 is equal to 64. So I need to find the value of x here. So for my solution, I'm going to first start by taking the power of 4 on both sides. So now I have x to the power of x to the power of 4 to the power of 4 is equal to 64 to the power of 4. Now, if I have something in the form a to the power of m to the power of n, this is the same thing as a to the power of n to the power of m. So I can switch the places of m and n here. So in this case, we can think of x to the power 4 here as m and 4 as n. So if I switch the places of these two, I get x to the power 4 to the power of x to the power 4 is equal to 64 to the power of 4. Now I'm going to replace 64 with 8 squared. So now I have x to the power of 4 to the power of x to the power of 4 is equal to 8 squared to the power of 4. Now, if I have something in the form a to the power of m to the power of n, this is equal to a to the power of m times n. So a to the power of 2 to the power of 4, that's going to equal a to the power of 2 times 4, which is equal to a to the power of 8. So I have x to the power of 4 to the power of x to the power of 4 is equal to a to the power of 8. Now I'm going to let x to the power of 4 equal to the variable y. So now I have y to the power of y is equal to a to the power of 8. And if I have something from a to the power of a is equal to b to the power of b, this means that a is equal to b, meaning y is equal to 8. Now remember how we let x to the power of 4 equals y. So if x to the power of 4 equals y and y equals 8, then this means that x to the power of 4 is equal to 8. So now to solve this equation, I'm going to take the fourth root on both sides. So the fourth root of x to the power of 4 is x, and so I have x is equal to fourth root of 8. So now to check, my original equation was x to the power of x to the power of 4 is equal to 64. X is equal to fourth root of 8, so now I have fourth root of 8 to the power of fourth root of 8 to the power of 4 is equal to 64. Now the fourth root of 8 to the power of 4 is simply 8, so now I have fourth root of 8 to the power of 8 is equal to 64. Now, this is the same thing as 8 to the power of 8 over 4 is equal to 64, meaning 8 to the power of 2 is equal to 64, and 64 equals 64. So this is right. Alright, so in this problem, I have x to the power of 3 plus x is equal to 10. So to solve this, I'm going to first start by subtracting 10 on both sides. So now I have x to the power of 3 plus x minus 10 is equal to 0. Now negative 10, that's the same thing as negative 8 minus 2. So now I'm going to switch the order of these and rewrite this as x to the power of 3 minus 8 plus x minus 2 is equal to 0. So now 8 is the same thing as 2 to the power of 3. So now I have x to the power of 3 minus 2 to the power of 3 plus x minus 2 is equal to 0. Now, if I have something in the form a to the power of 3 minus b to the power of 3, this is equal to a minus b times a squared plus ab plus b squared. So in this case, x to the power of 3 minus, x to the power of 3 minus 2 to the power of 3, I can rewrite as x minus 2 times x squared plus 2x plus 2 squared, which is 4, plus x minus 2 is equal to 0. So now if I factor out x minus 2, I get x minus 2 times x squared plus 2x plus 4 plus 1 is equal to 0, which is the same thing as x minus 2 times x squared plus 2x plus 5 is equal to 0. So now to solve this, I have two equations. I get x minus 2 is equal to 0, and x squared plus 2x plus 5 is equal to 0. So for x minus 2 equals 0, x is obviously equal to 2, so this is one solution. And for x squared plus 2x plus 5 equals 0, I can use the quadratic formula, which is negative b plus or minus the square root of b squared minus 4ac all over 2a. So in this case, b is equal to 2. So I have negative 2 plus or minus the square root of 2 squared, which is 4, minus 4 times a, which is 1, times c, which is 5, all over 2a, so 2. Now this is the same thing as negative 2 plus or minus the square root of 4 minus 20 over 2, which is equal to negative 2 plus or minus the square root of negative 16 over 2. Now the square root of negative 16 is the same thing as the square root of 16 times the square root of negative 1, and the square root of negative 1 is equal to an imaginary number I. So negative 2 plus or minus the square root of, square root of 16, which is 4, times I. I is the square root of negative 1 over 2, which is equal to negative 1 plus or minus the square root of 2i. So two more solutions. Alright, so in this problem, I have 8 to the power of x is equal to 80. So to solve this, I'm going to first start by taking the log on both sides. So now I have log of 8 to the power of x is equal to log 80. Now if I have something in the form log a to the power of b, I can move this exponent b to the front. So this is going to equal b times log a. So in this case, I have log a to the power of x, so I can move x here to the front. So now I have x times log 80, x times log 8 is equal to log 80. So now we want to isolate x here. So I'm going to go ahead and divide both sides by log 8. So I can move log 8 to the right-hand side. So now on my left-hand side, these two are going to cancel out. And now I have x is equal to log 80 over log 8. So now log 80 here, well, 80 is the same thing as 10 times 8. So I'm going to rewrite 80 as, log of 80 as log of 10 times 8. And if I have something in the form log of a times b, this is equal to log a plus log b. So in this case, log 10 times 8, that's going to equal log 10 plus log 8. And now I have this over log 8. So now to solve this, I'm going to rewrite this as log 10 over log 8 plus log 8 over log 8. Now, anything divided by itself is 1, so log 8, those two cancel out. So now I have log 10 over log 8 plus 1. And log 10 is also 1, so I have x is equal to 1 over log 8 plus 1. So log 8, that's the same thing as 2 times log 3. 3 times log 2, which is equal to 2.1074.